In the last lecture, we began a discussion on climate changes in the past. And we argued that we need to understand how Earth's climate changed in the past in order to be able to predict how it will change in the future. Now, in the past, human beings had no impact on Earth's climate. And Earth climate was changing due to natural causes. What are the natural causes? On the left here you see causes like plate tectonics, the movement of continents, changes in Earth orbit around the sun, and changes in the incoming radiation. These are external. Now, internal, there can be changes in the atmospheric composition, like carbon dioxide can change naturally. There can be changes in ice cover, changes in vegetation, changes in ocean circulation and land surface. All these changes will also influence Earth's climate, and as well as the energy exchange between the different parts of the Earth system, atmosphere, ocean, land. They keep exchanging energy all the time. That will cause natural internal variability. Okay. Now, our aim is to look at proxy data that has been collected over the last 50 years about how Earth's climate changed during the last 20,000 years, and whether we can explain those changes based on laws of physics and climate models. If we can do that, then we have the confidence that the same climate models can be used to predict how Earth's climate will change in the future. Now, one example is showing that millions of years ago, South America and Africa were joined together, okay, due to movements of the continents. So, that would have influenced the ocean circulation and hence the Earth's climate. So, Earth climate depends also on the configuration of the continent. We have one configuration now. It was very different millions of years ago. That would have had an impact on Earth's climate. Now, Earth's cryosphere, that is where ice is there, has a huge impact on Earth's climate because ice reflects solar radiation. So, ice is in the form of glaciers, snow cover in polar regions, floating ice, sea ice, and permafrost, which is frozen soil. All these have an influence on the Earth's climate by changing the albedo of the Earth. Okay? And in addition to ice, water in other forms like water vapor, stored water, evaporation, river flow, and rainfall, all these will influence Earth's climate. So, hydrological cycle is a very critical component of Earth's climate, and this cycle contains ice, liquid water, and water vapor. So, the incoming solar energy interacts with the geosphere, which contains atmosphere, the lithosphere, hydrosphere, cryosphere, as well as the biosphere. All these things interact with each other and determine what is the global mean temperature and the amount of ice cover and amount of vegetation. Now, you recall that we have to infer the past climate by an indirect method because there was no thermometer before 1700. So, we have to do a deductive work and try to infer what was the climate in the past through sediments from the bottom of the ocean, fossil shells. Shells contain information about what was the climate millions of years ago. Ice cores contain lots of interesting information about the past climate. Air trapped in the ice core tells you the composition of the atmosphere at that time. And speleothem, which are the deposits you find in caves, they contain information about what was the rainfall and temperature in the past. Okay? And corals in the ocean also tell you about the temperature of the ocean. So these serve as surrogates for Earth's climate. So these are of course indirect methods. So there are going to be some approximations involved, assumptions involved in inferring temperature. So there are going to be some error bars. Now today, because people have been able to use wide variety of proxies, we can infer the climate in the past, especially temperature, by using many proxies, not one proxy. If you use one proxy, there is a strong chance that it could go wrong, okay? Because when you are converting a proxy data like the abundance of certain life forms in the past being related to temperature, now that could go wrong sometimes. Okay? So in order to be absolutely sure that your deduction of the past temperature is not just dependent on one proxy which might go wrong, we use multiple proxies. If 2 or 3 proxies say that 20,000 years ago the earth was very cold, then you can believe it. Okay? So that's a huge advantage today, that we can look at many proxies, and if all of them agree and say that temperature was lower than the present, then we can trust that information. Now here are examples of proxies that have been used for the last 2000 years, and you can see clearly the most dominant proxy is the tree ring. Now tree ring gives you a very good idea about the temperature in that location, because when the temperature is higher, especially in mid latitudes and polar regions, when the temperature is higher, the tree grows more. Okay? So the width of the ring of each year's growth ring gives you an idea of the temperature. So this has been used in places like Europe, Russia and America to infer what the temperature was in those regions. Now this will not work so well in the tropics, where temperature is already high, so the growth of the tree in the tropics will be more sensitive to rainfall. Okay? Now there are many other things here. You can see ice core and lake sediments, corals and so on, and you can see that in the last 1000 years the dominant proxy has been tree ring. Okay? The other proxies' contribution is much smaller, but they help, because if the tree ring says the earth was warm and the other proxies say earth was cold, then one needs to be careful. If all the proxies agree that the temperature was warm at some time in the past, then we know that that inference is correct. Now here is an example of various proxies that have been used over the last 100 million years. Okay? In the last 100 years, of course, instruments were very useful. You have good data from thermometers. Then you can look at historical writings. Wherever people have written down the climate and weather of that location in some detail in historical records, you can use that to get some idea of the cold period and warm periods. Then of course tree rings, which I mentioned just a few minutes ago. Ice cores are the new source of new information. In the polar regions, we have lots of thick layers of ice, kilometers thick, and if you drill that and get a core, that core contains information about how the climate was in the past. Okay? Now same way, you go to lakes and look at the bottom sediments which are deposited at the bottom of the lake, take a core and find out how the sediment and the living things in that sediment, how did they change in the past, their type and variety, and that would respond to temperature and rainfall. Now similarly, corals, the kind of coral that exists depends on temperature of the ocean. Okay? So corals have been used extensively to get an idea of temperature of the ocean in the past. And the most important proxy data are ocean sediments going back to almost 10 million years or even 100 million years, because you can go into the deep ocean, drill as deep as possible and take out your sediments, and from the sediment data of living things which are deposited there, you can get some idea. Over the continents also there are sediments which can give you some idea. So, you can see that we have a wide spectrum of proxy data over a large period and they are overlapping. For example, between 10 to 1000 years you can get hold of at least 6 different proxies. As you go very fast in the past, of course, we have only 2 proxies, the sediments in the ocean and continents. Those are the only thing we have. That is why the quality of proxy data is very good in the last 10,000 years, but as you go back in time, things get a little more difficult. Now, here are locations where proxy data have been derived over the last 50 years. Some of them are over Antarctica, some are over Arctic, some are over land, and so you can see that the number of locations where proxy data has been obtained is more than 100. So, this is very good news. So, that if you take all this data and average over them, you will get some idea of the global mean temperature. But also note that the proxy data is missing in many regions of the world, like Indian Ocean equatorial region, Atlantic equatorial region and the Pacific region. Okay. So, so there could be some doubt about whether we can correctly get the global mean temperature by merely using these proxies. So one has to be careful, but people have looked at this problem very carefully and were able to show that proxies of this kind can be used to infer the global mean temperature, although they do not cover the entire globe. Now, let us look at the present condition on the earth. At present on earth, there is ice cover only in Antarctica, Greenland, some parts of Arctic here and some parts of Canada and North America and South America, and of course, Himalayas. Okay. The rest of the world does not have an ice cover which we can use. Okay. But remember that 20,000 years ago, there was a lot of ice cover over Canada, Greenland and Europe. Okay. This was the last ice age. Okay. This is going to give us a lot of useful information about what were the conditions during the last ice age. And this is very important because last ice age was 20,000 years ago. So, we would like to know how the Earth's climate changed during the last 20,000 years. And if we are able to get that, then we can use climate models to simulate how the Earth's climate changed during the last 20,000 years. We can use energy balance climate model, which we discussed earlier in the course, or more complex climate models involving general circulation of the ocean and land. And if the model simulates the evolution of the climate from the last ice age to the present correctly, then we can be confident that these models can be used to project how the climate will change in the future. Okay. This has been the major goal of all work on paleoclimate, the past climate, because we have been able to get fairly reliable data about the change in climate during the last 20,000 years and compare it with simulations by model during the last 20,000 years, and these two compare reasonably well, and hence we have developed confidence that these climate models were useful to understand what will happen in the future. Okay, that is the main goal of this work. Now, let us look at the last ice age. During the last ice age, 30% of the earth was covered with ice. Today it is only 11%. So, in the last 20,000 years, the ice cover over the earth has declined from 30% to 11%. That is a large change. Okay? And we need to know what caused this change. Okay? and how this change evolved in time. Okay. So, this is very useful information. We had ice covered with 30% ice during the last ice age, and that ice cover declined gradually, and today it is only 11% and is declining due to global warming, and we think that most of the ice cover may disappear in a couple of 100 years. So, if we understand how the decline in ice cover over the last 20,000 years took place, and if we can simulate the change accurately, then we can predict with confidence how the ice cover will change in the future. Okay. That is the goal of this work. Okay. Here is the ice cover during the last ice age, a close up of North America. There were two major ice sheets, the Cordilleran and the Laurentide ice sheets, which went up to North America, covered huge parts of North America with 1 to 2 kilometers of ice. And also note that because of the ice cover, Greenland was linked to North America. Okay. So, that is an important point in Earth's history. Okay. Now, here is an example of thickness of ice sheets 21,000 years ago. Okay. In Toronto, Chicago, Boston and Montreal. In Montreal, there was a 3.3 kilometers thick ice. It is difficult to believe it, but people have analyzed this data very carefully, and they can infer these thicknesses using proxy data. So, Boston had a 1.25 kilometer layer of ice, Chicago had 900 meters and Toronto had 2.1 kilometers. Now, when so much of ice is there over land, the weight of the ice is so large that it actually pushes the land down. The land will be depressed. Okay. So, many of these places now have no ice, all the ice is gone. Okay. And people have been measuring the rate at which land is rebounding. The land is slowly rising because rock has memory. Okay. Rock is not an elastic material. As soon as you remove the load, it does not recover quickly. If it is elastic material, if you remove the load, it will come back. If it is not elastic material, it has memory. If you remove the load today, it will slowly recover after many 100 or 1,000 years later. So, that is what is happening in many parts of Europe and in North America and Canada. Land is still rising because ice was removed from this land more than 10,000 years ago. Now, let us look at the ice ages that have occurred on Earth the last 600,000 years. Okay. We have data on that, and you can see increasing ice over land is shown here. So, there is 1, 2, 3, 4, 5, 6 occasions in the last 600,000 years when land had a large amount of ice. Okay. And so, every 100,000 years approximately a major ice age occurred. The last one was 20,000 years ago. So, this is a very interesting information we have, that Earth undergoes cyclic changes in the amount of ice, and this cycle has a period of 100,000 years. And this has puzzled a lot of scientists. What is the mechanism governing this 100,000 year cycle? We will not discuss that in today's lecture, we will discuss it subsequently, because there is a very interesting theories behind it, and it is not completely understood, but we have a fairly good understanding. But today's lecture will focus only on the last 20,000 years. Okay. Now, remember, when these last ice ages occur, lot of water from the ocean becomes ice. So, the ocean level drops. In the 20,000 years ago, the ocean level was about 120 meters below the present. That means the geography of the earth was different 20,000 years ago. Here is an example. When there was a maximum amount of ice, the land area was much larger than today. Okay. And as the more and more ice melts in the next 1000 years, the sea level will rise now and land area will decrease, okay, if there is no glacier. So you must remember that glacier alters the map of the earth. When there are a lot of glaciers, sea level drops and land gets exposed, and when the earth becomes warm, ice melts and the sea level rises, the earth map changes completely. Okay. This has an important implication in evolution of life on earth. Okay. Now today, between 28 and 35 million kilometer cube of water is frozen in glaciers, okay, all of which came from oceans. During the maximum extent of glaciations, more than 70 million kilometer cube of ice was present on the continents. Okay. Those 1 kilometer, 2 kilometer thick ice contained 70 kilometer cube of ice. And these huge masses of ice had impact on the climate of the glaciated areas, and they contained enough frozen water to lower the sea level by 130 meters. Okay. Now let us see what consequences it had. Because of the lower sea level, Asia was linked to this is North America, this is Asia. It was linked through what is known as the Bering Land Bridge. Okay. So 20,000 years ago, human beings living in Asia were able to walk across to the North American continent. And today with genetic analysis, people are able to show that Native Americans who are there today in North America, their genetic ancestors came from Asia. Okay. So this is the impact of ice ages on human beings spreading all over the world. This is also not really true of human beings, it is true of animals. For example, tigers and other feline species moved across to this continent. Now, how was it over Asia? Over Asia, you can see during the last ice age, India's map was different. Large areas near Gujarat were not covered with the ocean. Sri Lanka and India were together. Okay. And you can see large parts of Indonesia were completely free of ocean. And this was so different that 20,000 years ago, people living in India were able to walk right across to Southeast Asia, Indonesia, and the sea level was so low in this region that people were able to walk across to Australia. It is believed that the native people of Australia, called the Aborigines, they are genetically linked to South Indians in Tamil Nadu. Okay. So this shows how ice age enabled human beings to go over the entire earth because there were land bridges, because the ocean had gone down by 130 meters. Okay. So in India, all of you recall, there is a city called Dwarka in our mythology, which was supposed to be go underwater as the sea level rose. That Dwarka is right here. So today, people who do sea diving, they can go under the ocean and see an entire city of Dwarka, which has been submerged by rising ocean. Okay. So this is something we have to understand, because on account of global warming that is occurring, in the next 100 to 200 years, the sea level may rise by 1 or 2 meters. So large parts of Bangladesh will be underwater. So, studying past climate gives you a warning about what can happen in the future. Okay? So, this must be kept in mind. The learning about the past is very important to understand what will happen in the future. Okay. Here is an animation of how India's coastline varied during the last 25,000 years. Okay. You watch this animation, you see that 20,000 years ago there was a lot of land, and this land gradually disappeared and India's map changed. Okay. India was linked to Sri Lanka, and slowly the link disappeared 7,000 years ago. So, all these tell you that the map of the world does not remain constant, it keeps changing due to melting of ice or formation of ice. And so, as the global warming proceeds, we all have to be ready for a change in the map of various countries. As a matter of fact, the major fear expressed by many people living in small islands all over the world, that those islands may disappear on account of global warming. Now, here is a data on the sea level rise from 20,000 years ago to the present. Okay. You can see that 20,000 years ago sea level was around 130 meters below the present global mean. Locally it can be different, but globally, and it remained sort of flat and then started rising rather rapidly in some phases and reached almost the present value around 6,500 years ago. Then it's slowly increasing because the earth warming had slowed down by that time. So, this data is taken from various coastline all over the world. So, wherever coastline is exposed, paleontologists can, people who study paleoclimate can look at those coastlines and figure out at what level the sea was in the past. Okay. And now, this coastline sometimes change suddenly. This is because this ice which was there in the North American continent and Europe, it started melting and collapsing rapidly. So, what is to be remembered is ice melting does not occur slowly and smoothly. It is not like the ice melting which you take ice out of a refrigerator and put it on the table, it melts slowly. But these large glaciers and ice sheets, they undergo catastrophic changes. Okay? And we have to understand that because such things will happen in the future too. So, due to ice melting, the change in sea level will not occur smoothly. There will be periods of very rapid sea level rise when such events occur, when major ice sheets collapse suddenly, then sea level will rise rapidly. So, this is a warning that we get from the past. Okay. Now, here is an example of sea level rise. It was gradual in the beginning, but then there are sudden changes. This is called the melt water pulse 1A and 1B. Okay. And these two periods of rapid sea level rise were identified from New Guinea, and it is important to understand why this rapid sea level rise occurred over a short period of a few thousand years. And so, this is an important part of our understanding of future climate, because in the past 20,000 years, Earth's climate has changed rapidly during some periods, and we have to understand why this rapid climate change occurred, where sea level rose rapidly, then it rose slowly. So, right now sea level is rising very slowly, so we may be thinking it will happen like that in the future. No, if some of the major ice shelves collapse rapidly, then sea level will change much more rapidly as it happened in the past. So, because of this, it is very important to understand the climate change occurred in the last 20,000 years, and we will continue the discussion in the next lecture, where we will compare the climate change as observed from proxies with climate change that is simulated by climate models. Our aim is to both use the proxy data and the climate models to understand the climate change over the last 20,000 years and thereby gain more confidence about how climate will change in the future. Okay. So, that is the purpose of this whole this lecture and the next lecture, to enable you to be confident that our ability to predict the past climate change that is obtained from proxy data is quite good, and hence we will be able to predict the future climate change with some confidence. So, we will continue this debate in the next lecture.